Hi everybody, welcome back to Matthew 45. This week we are talking all about sets. On Monday we talked about what it means to list the elements of a set using roster notation. And then we talked about what it means for a set to have a subset or a proper subset. Today we are going to talk about some more aspects of sets like universal sets and empty sets. So remember, a subset of a set W is another set that contains only elements from the set W and could contain all elements of W. If A is a subset of W, this means that A contains only elements that are in W, then we write A is a subset of W. Remember, this symbol means that they could be equal. This is a proper subset, they can't be equal. The two sets. Now we have another definition, a universal set, and this is a set that contains all of the elements that we are interested in. This depends on the context of the problem that we're dealing with. A set that contains no elements is called an empty set. It is characterized by this funky looking symbol here, and it means that we have a roster notation list that does not have any elements in it. So the empty set is, kind of silly, but it is important sometimes, so that's why we learn about it. All right, so what is the universal set containing the months of the year? So remember, universal set means all of the elements we are interested in. All elements. So in this case, we want to list all of the months of the year. So I'm going to name this M for months. And I'm just going to list them in roster notation. So we have January, February, March, April, May, June, July, August, September, October, November, December. So this is the universal set that contains all of the names of the months in the year. Next, we want to determine a subset of this universal set that contains only the months with 30 days. So I'm going to call this T for 30. So which of the months contain 30 days? April, June, August, nope, that's not right, is it? September, sorry. June, September, and November. So these are the months that contain only 30 days. So using our subset notation, if I call this M and this T, I can see that T is a proper subset of M, since T only contains elements of M, but T is not equal to M. I could also write T is a subset like this of M, because this little thing right here doesn't mean that they have to be equal. It just means that they could be equal. So I can write either one of these to represent the relationship between T and M. All right, next I have T, the set T, with the elements math, chemistry, 111, 112. And I want to define 3 different subsets of T. So I can do lots of things here. But the first one that I am going to do is actually the empty subset. So I'm going to call A the empty subset, or we could also denote it like this, because the empty subset is a subset of everything. Even though there are no elements here, we define the empty subset to be the empty set to be a subset of everything. Maybe I'll write that down. The empty subset is a subset of everything. Okay, another subset that we could make is, maybe I'll say math 111. So I could write here B is a proper subset of T, or B is a improper subset of T. And finally, if I define C to be math, chemistry 111 and 112, then I would have to write C is a subset like this of T, since they are equal. I cannot write C is a proper subset of T. That is not right, because they are equal in this case. So that's it for today. It's a pretty short lesson, but hopefully you learned something, and I will catch you on Friday. Have a wonderful day.